Good afternoon to everybody. In my poster, I focus on our laboratory activity that we performed last year on the prototype of the PROSPECT imaging system. It is an imaging camera that was originally designed for the PROSPECT payload for the Luna-27 mission. Now migrated to the ECLIPSE mission with NASA. It is a visible and near-infrared multispectral camera that it will be mounted on the proceed drill of the PROSPECT payload and will take multispectral images of the lunar soil, and in order to characterize the terrain and also to monitor the drilling activity. The imaging system can acquire images by using the external light and also by taking advantage of an autonomous illumination. So, in fact, it also has a lighting system constituted by several LEDs that can illuminate the soil at 6 different wavelengths in the range between about 500 and 1000 nanometers. So we performed several laboratory activities on the prototype in our laboratory at INAF in Rome, and in order to characterize the scientific performance of the imaging system in terms of observation of both synthetic and natural targets, in terms of characterization of linearity of the detector acquisition, and we also characterized the LEDs emitting spectrum. So in this slide we can see some pictures of the experimental setup and of the results that we obtained in the laboratory. For example, in the top central top photograph, we have an image of the laboratory setup in which we can see the camera that is looking downward, a natural sample that is a volcanic rock, and we both illuminated with the camera LEDs and also with this external light source. In the central part, in the bottom of the slide, we can see an RGB image of this sample, and where we tried to evaluate the spatial sampling of the camera at a distance of about 20 centimeters. We have to say that this camera can image the soil at different distances from a few centimeters up to 40 centimeters. And then we also performed a dust deposition test in order to try to evaluate the decreasing of imaging performances of the camera after the deposition of dust on the optics following the drilling activities. And we can see in the panel 3 how the imaging of a volcanic sample can be slightly degraded after deposition of dust. So here we can see 6 different images taken at 730 nanometers of wavelength. And in each image, we have an increasing dust of layer of lunar simulant on a glass in front of the optics. So we can see how the imaging can degrade. In the fourth panel, we evaluated the emission spectra of the LEDs of the camera. So we have 6 plots of the spectra as function of the wavelengths, each at the central wavelength of the emitting LEDs. And we also characterized the spectra as a function of time in order to see any stabilization time of the LEDs. So Thank you, and I invite you to see my poster. Thank you.